Hi there, and welcome to this video on solving linear inequalities in one variable. In this video we're going to do a problem that has one solution, or in this case one solution set because it's an inequality. We're going to do a problem that has no solutions, and then we're going to do a problem that has all real numbers, our solutions. In this problem, you should be able to first identify like terms on the left side and combine them. You can do this by hand if you want. If you get common denominators, our common denominator is going to be 21, so we need to multiply each fraction by a form of 1, and we'll get 321 or 3/21 x plus 11 minus 14/21 x here is less than 4x plus 3. When we combine our like terms, we're going to end up with negative 11 21st x plus 11 is less than 4x plus 3. Okay, you have to do that before you can eliminate the x's on one side or the other. I like to go straight to the smaller number of x's, and we want to take those away from that side. Remember, when you take something away, you're either adding or subtracting. So if we subtract negative 11, we're going to be adding 11/21 x, and we need to do that to both sides. When you do that, you get the result of 11 on this side is less than, and on the right hand side, if you combine those, you get 95/21 x plus 3, which is kind of an ugly fraction, but don't let that bother you. You know how to deal with that. Subtract 3 from both sides, and you get 8 is less than 95/21x. And let's get rid of this multiplication by multiplying by the reciprocal. So if we multiply by 21/95, on the right hand side, those 95s will give us 1. The 21s will give us 1, and we'll be left with x. So our result is 168/95 is less than x. Or remember, you can rewrite this. If you want to write it x on this side and 168/95, you must also flip the inequality sign. And when we graph this, we have an open dot. Our 168, oops, that should be a 95, over 95 goes under our dot, and the x's are greater than that number. Okay, so this is an example of a problem where you get one solution set. In other words, all of the x values that work lie to the right of that number. Okay, this is what you're used to seeing. Now there are two other types of problems, and we're going to look at the solutions first before we kind of interpret the meaning of those solutions. So here's the second example I want us to look at. In the second example, we're going to start out with a problem that you need to use the distributive property to simplify before you start to solve. And we need to use it twice, once on the left and once on the right. So let's go ahead and do that now. The left-hand side becomes 8m plus 16, not 2. Remember to multiply both things. And the right-hand side becomes 20 plus 8m. Now again, we have variables on both sides, so we need to eliminate either the variables on the left-hand side or the variables on the right-hand side. We can't put those together because they lie on opposite sides of the inequality sign. So we're going to subtract 8m from both sides. When we do that, we have 0 m's on the left and 0 m's on the right, and we end up with 16 is less than 20. All of the m's have vanished. So what do we do when that happens? Well, here's what you need to do. You need to look at the inequality that you have and decide if that's true or false. That is true. 16 is less than 20. Now, true is not your answer. It's just a verification that what we've got is true. Our answer is there are many solutions. In other words, if we go back to the original problem, we can pick any value for m and it will work. And you can actually try that. If you pick 3, you would have 8 times 3 plus 2, which is 8 times 5, 40, is going to be less than 4 times 5 plus 2 times 3, which is 4 times, this is 6, 5 plus 6 is 11, which is 44, and yes, 40 is less than 44. That is true. It works. Try it with another number. It'll work for any value of m that you pick. So this is a case where all of the m's are gone. They disappear. When that happens, look back at your inequality, see if the result is true or false. If you answer that yes, that's true, 16 is less than 20, then you have many solutions, which means any value for your variable will work for your problem. All right, let's look at another situation. This we're going to contrast with the one we last did. So if you think about if you get a true result, the kind of antithesis of that is that you would get a false result. So let's see what happens when we get something that ends up being false. In this problem, again, we have to distribute before we actually work the problem out. So let's go ahead and take care of that first. When you distribute, you get 10z minus 20 is greater than 10z minus 10. And look at that right away. Those two things are similar. They're almost alike, but not quite. You have 10z's on both sides, but the number you're subtracting is different. So if we eliminate the variables from one side, let's subtract 10z from the left. If we do that, we have to do exactly the same thing from the right-hand side. You end up with no z's on the left, no z's on the right, which leaves you just with negative 20 being greater than negative 10. Now, remember what we said in the last problem. All of our z's have disappeared. Alright, so what do we do if that happens? We look back at our inequality and we think about that for a moment. Is that true or is that false? I'm going to draw a quick number line just to compare negative 20. Negative 20 is more negative than negative 10. My 0 would be here, my 10 would be here. So negative 20 is actually less than negative 10 because on the number line it's to the left of negative 10 or smaller than negative 10. So if I go back to my inequality here, this is false. It is not true. Negative 20 is not greater than negative 10. It's actually smaller than negative 10. So if we get a false statement, we have no solutions. So remember, the answer is not false. The answer is no solutions. In other words, there is no value for z that will make this inequality true. I hope this video helped you understand the difference between having one solution set, many solutions, and no solutions. If you need to go back and rewatch to see kind of how these compare and contrast, I highly encourage you to do so. Hope you enjoyed the video. Thanks.